with our properties of quadrilaterals, if you would please add two. One of them would be that the diagonals are congruent. So maybe put that at the top since there's not a whole lot of room on our checklist for quadrilaterals. And then down here at the bottom, I'd like for you to put that the diagonals are perpendicular. And we're just going to kind of just add that an extra row. And what I'd like for you to do is using the shapes that you built out of your Exploragons, I want you to look at your rectangle. Are the opposite sides congruent? Those I want you to look at, are the angles right angles? And I want you to put a check. It would be a good idea if you used pencil here. If you only have a pen, maybe just make a little dot in the corner. Because if you make a mistake, I want you to be able to erase it. Okay? So go ahead and take a minute, look at your Exploragons, put a check in the box. I'll get you started. Okay? A polygon with 4 sides is every single one of these. Okay? These are all polygons with 4 sides. They're all quadrilaterals. It would be a suggestion to go ahead and look at one at a time. Now, by the way, that's the only thing that you're going to check for quadrilateral. Okay? When we look at parallelogram, I want you to take your most general parallelogram. Not the rectangle, but tilt it a little bit. Okay? So tilt your parallelogram. And I want you to check, and just check all, I would do each column one at a time. So pick one shape. You have several here, so you have people at your table. Pick one shape and try to check everything for one shape at a time. Okay? See what you think. So we know that a quadrilateral is simply a polygon with 4 sides. There's nothing else to add to that column. The next column is parallelogram. So in the parallelogram column, are the diagonals congruent? No. Remember how I showed you one is much longer than the other because it's tilted, right? But the diagonals are in fact, I'm sorry, they're not perpendicular either. Let's keep going. Both pairs of opposite sides must be parallel. Yeah, that's the definition of a parallelogram actually. All angles must be right angles. Not necessarily. All sides must be congruent. Not necessarily. If I keep going, I believe that's the only other thing we can add to the parallel column. Okay? There are some other properties of parallelograms, and we'll add those to a different list in a few minutes. In the rectangle column, both pairs of opposite sides must be parallel. All angles must be right angles. And the diagonals are congruent. So that column has 4 checklists, 4 checks. The diagonals are congruent in a rectangle. And both pairs of opposite sides must be parallel. Okay? In a rhombus, the diagonals are not congruent because it's tilted, right, in a traditional rhombus. So one is much longer than the other. Let's keep going. Both pairs of opposite sides must be parallel. That's true. The angles don't necessarily have to be right angles, but all the sides are the same. And look at your rhombus for me. Can you do me a favor and try to think about putting the diagonals? Take 2 pencils. Take a pencil and a pencil of your neighbor and make the diagonals in your rhombus. Go ahead and do that for me right now. Make the diagonals in your rhombus. What do you notice about them? One's longer than the other, but don't they form right angles? Aren't they perpendicular? They are. So in a rhombus, the diagonals are perpendicular. If you're not sure what I'm saying, look up here. In a rhombus, try to make this as close to a rhombus as I can, this diagonal is much longer than this diagonal. Do you agree? Okay? So in other words, the one that I'm highlighting here is longer than the one that's not highlighted. But what is true is that these diagonals are perpendicular. They make a right angle. Okay, and that's something that's a characteristic that's true about rhombuses only. Okay, let's keep going. A square. Are the diagonals congruent? Try to make them with the pencil on your picture on your desk. What do you think? They are congruent. Both pairs of opposite sides must be parallel. All angles must be right angles. All sides must be congruent. God, a lot of things are true about squares, huh? Adjacent sides must be, let's see, diagonals are perpendicular. I agree. And actually, no, this is fine. Good? All right. That's true for a rhombus. This is kind of an odd one, and thank you for asking about that. This one is really talking about a kite, because adjacent means they touch, right? So you have kind of the top are the same and the bottom are the same. So really that property is really just referring to a kite, okay? That's why I had it there. Okay, let's keep going. What's the next shape? A traditional trapezoid. Not an isosceles one, but a regular old trapezoid. Exactly one pair of sides is parallel. That's true. And that's it. That's the definition of a trapezoid. And that's all I know. I have one pair of parallel sides, and that's it. In an isosceles trapezoid, I still have my parallel sides, but I also have one pair of opposite sides congruent. The legs are congruent in an isosceles trapezoid. And then there's something else that's true about the kite. Who has an idea? Look at your kite. What else is true besides the fact the adjacent sides are the two pairs? What do you think, Mo? Shh. Well, if we draw a kite, we don't have any opposite sides doing much of anything. Let me show you what I mean. If I'm going to draw a kite, we have two sides on one that are the same, and then we have two sides down here that are the same. Do you agree? That's a kite. What else? So we have it checked already. We have down here on kite that two pairs of adjacent just means they're touching, sides are congruent. I'll give you a hint. It has something to do with the diagonals. Draw your diagonals with your pencil. Daisy, what do you think? They are. If I draw in my diagonals here, here's one, and here's the other, what do you notice? They're perpendicular. Yeah, they form a right angle, okay? So that's true about kites. The diagonals are, in fact, perpendicular. Good. Okay? Do me a favor and go ahead and put these all back in the bag. I'm going to pause the recording for a minute. So now that we've started talking about, started talking about the different types of properties and the different kinds of quadrilaterals, we are going to go ahead and look at how they're all related to each other. So what I mean is, this is actually something called a Venn diagram, okay? And you're going to have a word list that I'm going to present to you. And actually, it is all of the words across the top here that you see. So I want you to take the words quadrilateral, parallelogram, rectangle, rhombus, square, put all of those words, and they're going to go inside here in one of these bubbles, so to speak. The Venn diagram simply shows you how they're related. So look at the properties. What do you think? Is a kite related to a rhombus? Is a kite kind of its own little thing? It is, isn't it? So kite should go over here because the kite is kind of its own shape. Remember how I took the rectangle and the rhombus, the rectangle and the parallelogram, and I went back and forth? They're related somehow. I want you to think about where those words go. I'm going to put them over here on the side, and you can drag and drop them, and let's see what words go where. So I really enjoyed a couple of different conversations I had. It was one of the questions that came up is, if I look at the properties of squares, it has the most checked, right? So it's the most of everything. Actually, a square is a combination of two things. If I take a rhombus and I take a rectangle and I make them together, it's a square. So that should clue us in as to where square goes. A square is both a rhombus and a rectangle. That's right. So in other words, if you look at the way these are set up, do you agree that if I have the rectangle circle, which would be here, and I have the rhombus circle, which is here, where do those two things overlap? In the middle. So that means that's where the square goes, exactly. So in other words, a square is both a rectangle and a rhombus. Good. We already talked about how kite goes over by itself. I agree. And then Shane said something interesting to his table as well. He said because rectangle, squares, and rhombuses are all parallelograms, then these are all parallelograms. Okay? Good. So the only two things we have left are trapezoids and isosceles trapezoids. Which one is the bigger general category? Trapezoid is the general one because it's just one that has two parallel sides. But more specifically, the isosceles trapezoids has two legs congruent, right? So it's the one that's kind of, and I'm just going to have to draw it so you can see it goes, it just doesn't fit in a little circle, right? I-trap is fine. Whatever, how that helps you remember. I'm good with that. Okay? So this is the quadrilateral Venn diagram. It shows us the relationships between the things. When circles overlap in a Venn diagram, that means they have things in common. When they're totally separate, they don't have much in common. Okay? All right, go ahead and flip it over. I want you to star number 5, because we haven't talked about that property yet, but we will in a few minutes. Okay? What I'd like for you to do is think about these sentences. Look at your Venn diagram to answer them. I think the Venn diagram is a good way to answer these questions. So the Venn diagram is going to help us make a decision as to whether we're going to write sometimes, always, or never in these blanks. But skip number 5 for now because we haven't talked about that specific property yet. So at this point, I agree with everything. I'd like us to look at the sometimes ones and write the case that happens. Why is it sometimes? What I mean is, in problem number 1, the angles of a rhombus are sometimes right angles. What kind of specific kind of rhombus has right angles? A square. So we're going to write square here because that is the justification. That's like the explanation. A square is both a rhombus that has right angles, right? If we look at number 2, trapezoids are never kites. Also true, if we look at our Venn diagram, trapezoids and kites do not touch. They're never kites. If we look at number 3, a rectangle is sometimes a rhombus. If I look at rectangle and rhombus, what is the special case where that sometimes happens? A square again. If I look at number 4, the diagonals of a rectangle are sometimes perpendicular. What special case, what kind of a rectangle happens when the diagonals are perpendicular? What kind? It can't be just a rhombus. It's a specific kind of rectangle, so it's a square. We'll come back to number 5 in a minute. The diagonals of a parallelogram are sometimes equal. parallelogram has congruent diagonals? Be more specific, or more general, I should say. All rectangles. Also true for squares, but all rectangles are parallelograms that have congruent diagonals. Number 7, that's the definition of a trapezoid. It's just one pair of parallel sides, so it's always true. We struggled a little bit with this, okay? You can see it coming back. It's going to happen again. So it's good to study, okay? What I'd like to do is go ahead and flip back to your Venn diagram for a second, because I want to look at some special properties of parallelograms in general. So, I want us to look at just parallelograms. And everything inside parallelograms, the following 5 things hold true. So I want you to, these are all the properties of a parallelogram. I'm going to list them. I want you to list them off to the side. So not for trapezoids and not for kites, but specifically for parallelograms. One is that both pairs of opposite sides are parallel. And it's both pairs. And we know that. We built them, didn't we? The opposite sides are parallel. And that's true for every single thing inside the green circle. All parallelograms, that's true. You writing this down, Will? The next thing is that both pairs of opposite sides are congruent. Okay? Another property that's true for every single thing inside the green circle. All parallelograms have this true. We also have something true about the diagonals. The diagonals bisect each other. What do you think that means? What does bisect mean? Good. I like that, Gunny. Exactly. You can cut it in half. So when I look at just a general, let's just draw one. If we have one drawn. A general parallelogram. Do you agree that that's not a rhombus? Just a regular old parallelogram, right? When I look at the diagonals of this parallelogram, when I say they bisect each other, what I mean is this. This one's cut in half, and this one's cut in half. They bisect each other. That's what that means. That's true for any parallelogram. They're cut in half. The diagonals bisect each other. Okay? What else is true about a parallelogram? Well, here's one that's kind of by itself, so I'm going to just draw it down here. You ready? Oh, I know. One more, actually. One more about the angles. Opposite angles. So what do I mean by angles? The angles on the inside, right? So the angles across from each other are the opposite ones. They're congruent. That's true in any parallelogram. Opposite angles are congruent. So what I mean is this. If I have any parallelogram at all, and I know that this angle is 120 degrees, what other angle is 120 degrees? The one down, yeah, the one down here in the bottom right. Okay. Actually, because these are parallel lines, don't I know something about the top right angle too? That's not 120. What's this one going to be? It's going to be 60 because they're supplementary. They're consecutive interior angles, if you remember that. Okay? All right, last property, I'm going to kind of put by itself, put a little squiggly line, because it's a certain way to prove, I said the word prove because it's a way to prove something's a parallelogram. If I have one pair of opposite sides that is both parallel and congruent, then it has to be a parallelogram. And I'm even going to write that this is a way to prove, all the others are as well, but this is a way to prove that something is a parallelogram. There's no way if I took my exploragons and tried to build a parallelogram and I had one pair of opposite sides that was both parallel and congruent, there's no way it couldn't be a parallelogram. It wouldn't make any other shape. Okay? So, just to review, all the properties of a parallelogram. Both pairs of opposite sides are parallel. Both pairs of opposite sides are congruent. The diagonals bisect each other. Opposite angles are congruent. And one pair of opposite sides is both parallel and congruent. Okay? So, I want you to use, let's go back to this sometimes, always, never, number 5. Now we know something about what bisect each other means. In a rhombus, do the diagonals bisect each other? Sometimes, always, or never? Always, because it's always a parallelogram, isn't it? As a matter of fact, if I look at my rhombus, here's something interesting. Well, this is true. The diagonals do bisect each other because it's a parallelogram. Always. Good. Question? Okay. One more thing before we jump to the bottom. Because often, wrong shape, sorry. Often, the SOL, at least on the release questions, look at rectangles specifically. Okay? Look at the rectangle that I've drawn on the board, please. If I were you, I might write this picture up in the corner, like up here somewhere, or down at the bottom somewhere. But specific to rectangles, it's an emphasis. Okay? So draw a rectangle. Good. I know that in a rectangle, this is true. I want you to draw the diagonals then. Draw the diagonals in a rectangle. I'd like us to think about, for a minute, several things. And we're going to come back to a rectangle towards the end of class today. But I want us to think about this picture, and just specifically about the diagonals of a rectangle. Do they bisect each other?
Yes.
Always, because it's a parallelogram. Doesn't matter. What else is true, Tony, about the diagonals in a rectangle? Look at your checklist if that helps. Look at the rectangle column. What else is true about the diagonals in a rectangle? Did you complete your checklist?
No.
So what does it say in the diagonal row for rectangle? What's checked? Don't look around, I'm asking you. think you have your checklist complete. So I'm going to come back to that so you can complete your checklist in a minute. But the diagonals are actually congruent, which means that when they bisect each other, this happens. Okay? So be careful how you drew that. Look at my diagonals. Because they're congruent, which means all the pieces are the same. Okay? That's important. And that only happens in rectangles. Okay? Well, square is a kind of rectangle, so it'll be squares too. All rectangles happens. Okay? All right. So what I want you to do now is look at this, and I want you to decide what kind of shape. They're not drawn to scale, so just look at the information that's labeled on the shape. So just because it looks like something doesn't mean it is. Okay? Look at whether we have arrows, which means parallel, or whether we have little segments, which means congruent. So I want you to think about what kind of shapes these all are. I will tell you that one of them is none of the above. We don't know what it is. One of these we don't have enough information to say. Okay? But everything else has a name. So take a minute, look at your properties, look at your Venn diagrams, and let's decide what they are. If we look at problem number 8, Martin, since I did it with you, tell me what information we know about number 8. I have one pair of opposite sides, only one, and that one pair of opposite sides is both parallel and congruent. If we look at what we wrote next to our Venn diagram, in red, at the bottom, under the squiggle, isn't that what that says? One pair of opposite sides that's both parallel and congruent. That's a way to prove that something is a what? Parallelogram. So I know that number 8 is parallelogram. Okay? Number 9. That's just a general category. That's actually the definition of one of these. What is the definition of? Parallelogram. Okay? Number 10. This one is different. Good. I saw lots of different things as I walked around. This one, we have one pair of, it's not drawn to scale, by the way, folks. If we know for a fact that these two are parallel, and I know for a fact that these two are congruent, okay? I don't like the way it's drawn. Let me draw it a little different way. Parallel and congruent. What kind of trapezoid? This has to be an isosceles trapezoid. That's the only thing that will work to guarantee it. Okay? So I just redrew it because I think the picture is misleading. But if we draw it accurately, where we have two congruent sides and two parallel sides, we know for certain it's an isosceles trapezoid. How about number 11? It is none of the above. If we label BE and ED being congruent, and then again up here, AB and DC being congruent, I know something about the diagonal and I know something about a pair of sides. I don't know what that is. Okay? Just some regular quadrilateral. I don't know. Okay? Not enough to categorize into anything specific. I like when I walked around, a lot of you got the right answer for number 12. What is it? It is a kite. Very good. Excellent. And then what about 13? It's a rhombus. Oh, good. Folks, please listen. You're going to have a short quiz on Friday on these properties. Okay? So it's important that you have, it could look very similar to this. Sometimes always never. It might have pictures on the bottom where you have to tell me what shape it is. I might provide a checklist. I might provide the Venn diagram. So this is your study guide for your quiz on Friday. Okay, on properties of quadrilaterals. Any questions so far? It'll be a short quiz. I'm not giving you the whole period. Alyssa, what you doing? My dog is if you don't mind putting that away for me. All right, what I'd like to look at is this particular question, and I want to change it to the length of AB. Okay? So, it's not on this sheet. It's just an extra question that I have for us. And I want us to look at this question and look at the picture. Maybe if it were me, I'd write it down on this paper somewhere. If I was thinking of trying to study for my quiz. Maybe I would write this down as example 1 in my notes on this paper. There's room at the bottom, so I might suggest drawing the picture and labeling what we know. We have it being as A, B, C, D. We have them intersecting at E in the middle. So label them with the points and the names. Label AC as 25 and BC as 15. Because it's a rectangle, I know some things. I'm going to highlight my AC. I'm going to highlight my BC because it's giving me those information. I know that BC is 15. I know that the yellow line AC is 25. I'm trying to find AB. So I'm going to label that as an X. There's a reason why I highlighted it in my picture, because I wanted to stand out. What kind of a shape do you see that's highlighted in the picture? It is a right triangle. And that's exactly right, Mo. We have a right triangle. Rectangles produce right triangles. Actually, so do rhombuses. But they're just in the middle. They're inside the triangle. Halfway. I have a right triangle here. I have two pieces of information. I need to find a third about their sides. What theorem do we know that will help us solve it? The Pythagorean theorem. Excellent. So we need to write it. Kiana, tell me what I write. 15 squared. Oops. Weird. 15 squared plus x squared equals 25 squared. Make sure you understand. Make sure you understand the question. Make sure you understand the formula. Are we okay so far?
Yeah.
Now, I asked you guys not to get outside Ellis.
Are you not going to solve one of these on
Possibly, yes. That's why I'm doing it. Okay? So, I know you don't have calculators, so I'm going to do it for you. 15 squared, 225. 25 squared is 625. Kevin, tell me what I do next to solve this. Trying to solve for x. Beautiful, great. Let's subtract 225. And I get 400. I agree. X squared equals 400. Tell me, Daisy, what I do next. Beautiful. So when I take the square root of 400, I get 20. Is that, I changed the problem. Is that what I'm looking for? Does that answer the question? Yeah. So I know that AB is 20. Because I used something I already know, the Pythagorean theorem, to solve it. But I used the Pythagorean theorem in a rectangle. That's okay. All right? We also have other ways to use the Pythagorean theorem. Please listen one more time. Here we go. This one. No, this one. Can someone think about looking at this picture? First of all, what shape is it? It's a rhombus. Can I use the Pythagorean theorem in this picture? I'm going to highlight one of the right triangles. So if I knew something about those parts, could I find a missing side? Okay? So the Pythagorean theorem can be used in rhombuses. It can also be used in squares. And it can also be used in rectangles. So that's not in a parallelogram, though. We have no traditional right angles. All right. Next class, after your quiz on the properties of quadrilaterals, we're going to be looking at, please listen, we're going to be looking at graphing. So I gave you 3 points of a quadrilateral. Can you find the fourth that will make it a square? Could you find the fourth that would make it a parallelogram? And that's what we're going to be doing next.